Welcome back to the Mechatronics instruction tutorial on getting software set up for working for the class. This is applicable to other classes as well, but I'm going to focus on Mechatronics 1. You may have to use different projects. If you followed my previous project, then you've already installed Subversion and you've checked out a copy of the templates. If not, you can use the default templates and that will also work. But we're going to assume that you already have the templates out and they're already in a folder called T441 Mech 2016. For other Reykjavík University courses, this folder will be called something else. Let's get started by installing MikTeX. We do that by going to the MikTeX page. And you'll notice here, there's a download link. An important thing to note is that for all the versions of Windows, including the 32-bit and the 64-bit, you should only install the 32-bit version of the installer. We've had problems with the 64-bit versions of Windows 8, 8.1, and 10 with the 64-bit installer, so we found that it's best to just have everyone install the 32-bit installer. So we grab it, wait a few moments for it to download it and for the virus checker to check it. We install it. We say yes to do and install it. We accept the MikTeX copying conditions. And now we get into another trick, which is that we've had trouble with Windows 8, 8.1, and 10 if you pick anyone who uses this computer. There's a problem with the package update manager whereby if you pick this, sometimes the packages don't get updated. So it's in your best interest to just say only for the current user. And we will install it in the app data folder, which is a hidden folder for local applications for this user only. And now we get to another trick. Install masking packages on the fly. You always want to say yes to this, unless you like answering yes 200 times the first time you LaTeX a document. I don't like doing that, so I always say yes. And this all looks good. We hit start. And now we wait for a little while it loads the package database from the internet. We can scroll down to see all the cool things it is doing. It's installing a bunch of standard packages that are used in most documents you will ever write. MikTeX is neat because it's an automated package installation system for LaTeX. So when it detects in your document that you need a particular package, it will do its best to download a copy of it from the internet and install it for you. Great, it is now finished. We don't bother with release notes, we don't care. And now a very important step that is often forgotten is the first thing we need to do with MikTeX before we do anything else is we need to run the update manager. We go down here, we scroll down to MikTeX, we expand it, and we go to MikTeX Update. The defaults are usually fine. And now we get to wait a few minutes while it goes and detects what the latest versions of various packages are for us. If you don't do this after installing MikTeX immediately or running it every once in a while, you're likely to get older versions of packages. And some of the older versions of packages have bugs that they fixed in the newer versions. So it's very important every once in a while to run the update manager so you can make sure you're using the latest version of the LaTeX packages. Alright, since this is the newest version, it seems to have gotten only a few files that need to be updated, so we say next. And next, and now we are done. This is the basics of getting MikTeX installed. In the next video, we'll be showing you how to get TeXStudio installed. Now that you have finished installing MikTeX, it's time to install the user interfaces for both working with LaTeX itself and also working with the citations. The program that you need to install for working with LaTeX itself is a wonderful client called TeXStudio. It has a spell checker and a bunch of other very useful wizards for making your document without having to know all of LaTeX yourself. It has a lot of help that can help you find how to solve the problem you're doing, and in particular for making tables and math, it has a lot of very helpful features. So we're going to install it now. While that's going, we're going to start installing JabRef as well. So we go to Downloads, Download Latest Release. And it doesn't matter which order you install them in. JabRef 64-bit if you're using a 64-bit operating system. You may have to install Java itself, but I have found that with many versions of Windows you don't have to do that. Let's install TeXStudio first. We say yes. English is a good language. Next, next, next. I usually just leave the defaults. Finish. This will fire up a TeXStudio window for us. But we might as well finish installing our software while we're at it. So we'll install JabRef as well. Now mind you, you can edit the LaTeX files directly. You don't have to use TeXStudio, but I found that for people getting started with LaTeX, it is extremely helpful. And you can also edit your citation lists manually, which is what I do personally when I'm working with a lot of entries. But JabRef is very nice because it keeps you from making the common mistakes that make your citations just break. And I don't want it to stop right down. I'm going to associate to BibTeX. And sure, I'll run JabRef as well. I'll move our window out of the way. Now assuming that TeXStudio is started up correctly, you'll get a blank window like this. And now it is time to see if LaTeX is installed properly. Most people will want to immediately go to Options, Configure TeXStudio, and pick the language that they're working with, which is under Editor. Right now the language is, language checking. Right now it's set to English US. On the older releases of this, it was always set to German. There's no Icelandic dictionary installed by default, but you can install one later. But English US is probably the one you want. In addition, you will want to set the quotes to be, depending on which packages you're using, you'll want to click some of these, and then TeXStudio will know automatically how to fill in things the rest of the way. I use the URL package. I use FixMe a lot. I use GraphicX. I use HyperRef. Let's see here. I use almost all of the AMS packages now and then. I use the array package. Sometimes I use Babel. Often use BibLaTeX. If you make presentations, you use the Beamer packages. Book tabs as well. Calculation allows you to do some math inside of a LaTeX document for calculating sizes. Color and Xcolor. Actually, Xcolor is better. Smart quotes. Fancy header. A toolbox. Geometry. Listings I use a lot. Math tools for printing, making nice math. MHChem for chemistry. PDF pages for including PDF into a document. You'll notice that when you hover over things, TeXStudio will try to tell you more what is going on with a given option. Subfig and subfigure I use sometimes. SV and multi we use sometimes. Tabular X we definitely use. TeX some people like to use. It's a way to do drawings directly in your LaTeX document. But I think this is a pretty good place to start. Go back to general. Everything looks good here. Commands. If any of these are blank or say unknown, hopefully that means your package is uninstalled. If you have Subversion with the command line option installed, hopefully these will be filled in, and then you can use these SVN options inside of TeXStudio to just check in your files. We check these. These allow us to change how the hotkeys work. By defaults usually work fine. One important thing is to make sure that the default encoding is UTF-8. And we can set advanced options, which we'll need for one thing that is often a problem is quotes, which I thought was here. Replace double quotes with English quotes is generally what you want as well. So this is a good set of options. There are probably others that we can do. Automatically load included files is a good idea. If you open a LaTeX document and it includes other files, this way they will automatically be opened in other tabs. There are all sorts of other options here, but I don't have time to go. I don't feel like going into them now. And you don't need them anyway. Now you look, this is a standard editor window. Let's just make a quick document to try playing around. So I said new from template, and let's make a random article. So we say OK. You notice the structure of the document is pretty basic. I fill in the title, my title, author, my name, and then this command make title turns it into a title. The abstract text goes here, short summary of my article. And the section, first section. Now we can test to see if LaTeX was installed correctly by clicking on the double green arrow. If you want to just build it, you hit the single green arrow. If you want to actually see what it looks like, you hit the double green arrow. And this little pop-up will come to tell you that the hotkeys have changed. We don't care right now. After a few moments, we should see our document show up on the right. You notice that this layout looks a lot like Overleaf, if you're using Overleaf right now, and that should not be a surprise. That's because many of the same interfaces and the concepts are used in both systems. We'll show some of Overleaf in another tutorial. But now we know that our LaTeX is working, and we can open a much more complicated example to see if it works as well. So I'm going to close it here. I don't actually want to save it this time. And I'm going to go open my, not instructor repository, but on the desktop, the repository we're in. And if you go into common, there's under template, there's a bunch of templates for the various things used in the Mechatronics class. A good place to start for testing if things work correctly is in the report templates, and a good one for testing out some features is either basic report, instructions, or proposal template. We'll use proposal template because this is the first assignment used in the Mechatronics course. If we double click on it, and it's already associated with TeXStudio, it should open in TeXStudio and we should be able to see if all of the options work. There we go. Oops, no, it's not associated with TeXStudio. I have to right click on it and say open, say properties. And now I can associate all these files. Instead of TeXWorks, which is the default that comes with MechTeX, I can say I actually want these to be opened by TeXStudio. And now all those files are associated with TeXStudio, which is what I actually want. And now when I double click on it, it opens TeXStudio. Now you'll see example proposed details shows up at the top, but we still see the old graphic because we haven't run LaTeX on it again. I hit the double green arrow, and now it will run LaTeX on it. TeXStudio is smart enough to look at the structure of your document and figure out if you need to run additional commands. In particular, this document has some citations in it, so it knows that it needs to run a citation command as well. The first time you run LaTeX on a complicated document, it will take longer than normal because it's installing packages. To see that, we have to click on log file, and then you can see that things are going on. So it's walking through, checking the Unicode, installing some fonts, Now there's a bunch of warnings, which are to be expected because the citation run has not finished yet. Now it's going to run the citation command called bibtech, which will then go through the citations listed in references.bib, extract out the ones that are relevant, and put them in a separate file, which will then be included as the citations at the end of the document. Right now, Mechatronics has detected that it's using the IEEE style for citations and downloading the IEEE bibtech style template and then applying it to the document. You notice now the document on the right has finished completing. There's some features of note. There's this draft in red at the top. That is a special option that's related to this draft at the top of the document class. Now that we know things are working, I'm not going to show more about the LaTeX document. We'll show more about that in another video. But I'm going to switch now to making sure that JabRef works. So I'm going to close this window and go to JabRef over here. And it's opened some other file that I had opened previously. So now I'm going to open the one that's related to the document we're looking at, which is references.bib. Bibtech files end in .bib. You can drag and drop them into JabRef, and then they will open. And now we notice there's a whole bunch of entries, and they're divided into different columns of information. Let's say that we wanted to add a book to our list of references. In particular, let's see if they've got the textbook for the class is not here. That sounds like something. Oh no, the textbook for the class is right here. And you can see that if we click on it, it quickly shows a summary of what is inside there. But let's say we want to add another book. Let's say Zen and the Art of Motorcycle Maintenance, which is a book published in 1973. So we click on the plus sign, or one of the other signs, but plus is nice thing. Click on book. And now we start filling information. Book was written by Robert M. Persig. Title is Zen and the Art of Motorcycle Maintenance. Year 1974. Date we can skip usually. Bibtex key. This is something that will be a mnemonic for you to remember this particular citation. The mnemonic that I use is the first author's last name, the year, and usually the first word of the title or some short description of the title. So in this case I'm going to say Persig 1974 Zen. Now, an important thing to notice is that when I wrote this, what's known as bibtex key, I did it in lowercase. You can use a mixture of uppercase, lowercase, numbers, letters, dashes. I would not use anything other than dashes, letters, numbers. We've had trouble with certain characters causing problems. If you choose uppercase and lowercase, one trouble is you have to remember which letters did you make uppercase and which ones did you make lowercase. As long as you pick one system and be consistent, it tends to work. Now that I've added my entry, I go to the optional fields. Is there anything else I want to add? In this case, I would like to put that the publisher was published by, and we can look this up on Amazon if you ever have this question. I want to find out who this is published by. Published by Harper Torch. And there's other fields too. I can fill in as many as I know. Some of them matter, some of them don't. The publisher and their location is often useful because then you can figure out how to get one of the copies of books. But in this case, Amazon is not putting it. So we'll just put what we know, and that's good enough. Once we're done with this, we say close here. And now our document is shown here, and there's a quick preview here so we can see what it looks like. If we need to go and manually change something because we know that it's not doing the right thing, an example would be if you needed to put a company website, then you would need to put double quotes around the name. Let's do an example of that. Say we need to put a link to a website like google.com or something. We might call it under electronic or miscellaneous. It's up to you. Electronic is probably a good one to use in this case, or www. If we go to required fields, author in this case would be Google Webs Corporation. Header we can skip. Title, Google search engine. Year, just put this year because we're talking about it right now. Date we skip. URL, www.google.com. BibTeX key, Google URL or something like that. Google 2016 Google URL. That's a good one in this case. Optional fields, all this stuff is fine unless we want something in particular. BibTeX source, you'll do this. When you're talking about a corporation, if you want to see a preview of what it looks like, where is this? If we close this now and double and click on it, wherever our Google has gone, where did it go? Google search engine, here we go. It says the author is corporation G. That's not what we want. For corporations, we often want the full name of the corporation, so we have to change the code a little bit. What we need to do is put double curly braces around the author. Putting curly braces around something inside of curly braces in BibTeX says don't mess with this. So in this particular case, it's not going to divide this into thinking this is a first name and a last name. So we save it now and close. And now it says Google Corporation here. That's exactly what we want. Let's say we were going to do an article from the internet about something. Let's say maybe axiomatic design and parachutes. He activated parachute system. Oh, that's already in here. If we look at the structure of the document, there's a lot going on here. There's a bunch of required fields, and if you'll notice, we've put curly braces around the first letters in the name. This is because by default, BibTeX will make things lowercase. If we put curly braces around something, it says don't mess with it, and so when we actually put this in our document, it will stay uppercase. Another thing of note is if you look at the authors, the way we separate names is with the word and. If you use commas, BibTeX thinks that that's part of someone's name. So if we said Gudmundur Bragason, comma, Steinar Thorsteinsson, comma, Rutur, etc., then BibTeX would get very confused because it would think that each of these commas is a different part of someone's name. You'll also notice in the example here, we have used Icelandic characters. If you're using BibTeX, this is actually a bad idea. BibTeX doesn't know how to deal with these characters, and in fact you will have to switch them to the LaTeX equivalents to make them work. We'll show that in another video later. Optional fields here are some DOI and pages. And then there's a special field here called Crossref. This is because there's another entry called ICAD 2015 that fills in the same fields that are true for all of the conference proceedings from 2015 at the International Conference on Axiomatic Design. I didn't want to have to type that in 10 times, so instead what I did was create one citation, shown here, which has everything I need to know about all the papers that were published at that conference. Then I use a crossref to point at that, so I only have to do that once. So we'll assume our JabRef is doing well. Let's put a citation into our document. Best thing to do when you do this is to save JabRef and close it. If you save it, then TeXStudio will probably reload the file. So let's close our JabRef, go back to here, and go back to our example proposal detailed. And let's go put a citation into it to Zen and the Art of Motorcycle Maintenance somewhere. How about at the beginning? Introduction. Maybe we need to think about Zen. And now we're going to cite it by saying This little twiddle mark is called a non-breaking space, which will keep the citation near that particular sentence. Cite. And one of the amazing things about TeXStudio and other tools like it is it can guess what you mean. So as long as I remember a little bit about the thing I want to cite, I remember the author's name started with P, it automatically pulls up a preview of all the information that's in the references.bib file that I just edited, and now I hit return and it fills in the rest for me. Now when I run double green arrow, I should see my citation appear. And if we look, there's a citation to Zen with the number 1. In many editors, if I click on it, thanks to a package called HyperRef, it will take me directly to the references. And you'll notice it's all filled in, everything is hyperlinked, and so therefore our citation system is working. That is all I'm going to show in this video. In another video, I'm going to talk in more detail about how to work with the elements inside of a LaTeX document. Thank you for watching.